everyone, and welcome back to our functions lessons. And in this lesson we are looking at the introduction to the parabola. Now that is a quadratic function. Now basically in grade 10 the parabola is of the form fx, or in other words y, equals ax squared plus q. Now this is a quadratic function because there's x to the power of 2. So don't forget that a parabola is a quadratic function. It's got an x to the power of 2. Now let's look at these values. The a, which is the coefficient of the x squared, right? Because that is the coefficient of the x squared. Now that a, which is the coefficient of the x squared, tells us if the legs are going up or down. So is these legs pointing up or are the legs pointing down? Now, if a is positive, so if that is a positive coefficient, the legs are going up. Okay, so if a is greater than 0, the legs are going up. If a is negative, in other words, this coefficient is smaller than 0, it's a negative number, the legs are pointing down like this. Okay, great. Now, what is the plus q? That is the y-intercept. So in the linear function we had a plus c, but here we just have plus q. Okay, so plus q is the y-intercept. Now, let's look at what the parabola looks like and the changes that you can expect in grade 10. So, let's look at the first one, y equals x squared. Now, let's just make sense of this. Do you see that the coefficient in front of the x here is a 1, okay? And it's a positive value, so a is positive, and when a is positive, the legs will point up. So that's why this parabola, the legs are pointing up. Okay, now look very closely. This is plus 0. So what is my q? It is 0. So where does it touch my y-axis? It touches my y-axis at 0. Okay, brilliant. Now let's look at some changes. If this is the normal function, what happens if we take that y equals x squared and we plus 2? That plus 2 basically means that this parabola moves up 2 places. Now let's look at this. So again, what is my a? My a is a positive 1, so the legs are pointing up, okay? And then what is the plus 2? That means that this normal function moves up 2 places. Now let me show you here in purple. So basically, if this was my normal function, that is the y equals x squared, the only thing that changed now is we added 2, plus 2, right? So this one needs to move up 2 places, and there we go. So look, where's my y-intercept now? It's at 2 because it's plus 2. Okay, brilliant. And then how about the next one? Y equals x squared minus 1. It's still, if I close this minus 1 with my arrow like this, I'll just quickly close it. And there we go. The y equals x squared, that is this red function. It's the same as that red one, but now minus 1. So that means this red function moves down 1 place. So it will basically look like this. Okay, so there it is normally, and now it moves down 1 place, and there we go. Okay, so just a quick couple of tips. The bigger that value, the bigger the coefficient of x squared, the bigger the numerical value of a, the narrower the legs will be. Now here, the a was all the same. Okay, so there's another one. So the a had the same value for all 3 of these functions. So what happens if it's a 2x squared? If it's a 2, these legs of the red parabola will just go a little bit narrower, okay? If it was a 5, it will go even narrower. So basically, the legs will just be narrower, okay? So it will close in on the y-axis. Now, this plus q, that just tells us if the graph is moving up or whether the graph is moving down. Now usually I always keep this in mind. If we have a minus q but a positive a, we are going to have x-intercepts. If we have, for example, a plus q and a negative a, so the signs are opposite, we're gonna also have x-intercepts, but we will look at that in due time in the next couple of lessons. As long as you know now that this plus q tells us where the graph goes through the y-axis, That one at 0, this one plus 2, there we go. This one minus 1, there we go. And then this basically, the A tells us if the legs are going up or down. And in the next lesson, we will learn how to calculate these x-intercepts, which you already basically did when we learned about quadratic functions earlier on in the year. Okay, let's go and look at some more examples. What if this A is now negative? We know that the graph will be pointing downwards. Now here we are going to just be reminded of what is the A. The A is the coefficient of the x squared, and that tells us if the legs are going up or down. Now, if A is positive, the legs are going up, like our previous examples. If A is negative, the legs are pointing down, and that's what we will look at today, and in this part of the lesson. Q is the y-intercept. So let's have a look at the normal function, the red one here. Okay, y equals minus x squared. So what is A? A is actually minus 1, right? Because it's minus 1 is the coefficient in front of the x squared. Now, when it is negative, the legs are pointing down. What is my Q? It's plus 0. So where will this graph start? It starts on 0 and then the legs are pointing down. Okay, brilliant. Now, how about the purple one? Again, A is minus 1. But where does the graph start? Well, it's the same as this one because it's got the same A, it's got the same coefficient for the x squared, but this time the graph is moving 2 places up. So let's just start on the normal place and then I'll show you what happens, because now it's the normal graph like this, but now plus 2. So this purple one moves up 2 places. There we go. Okay, great. So this basically means that's a positive, that's a negative, 2 opposite signs, so we will have x-intercepts. Okay, brilliant. Now, how about the blue one? It's still the same function, but now it moves down 1 place. So if that is my normal function, the blue one here now on the red one, but now it has to move 1 place down, so it starts basically at minus 1. There we go, and that's what it will look like. So please remember, we always go and look first at the A and the Q, and then we know where it starts, we know which way the legs will point, and then we can easily see if there's going to be x-intercepts, we can calculate it with our quadratic equations. And that's what we will do in the next lesson. So I hope you could follow what's happening here. See you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.